Hello everyone. Welcome to another lecture series presented by the 100% Dialog group. So this will be regarding permutations and combinations. So we'll be looking at the very basic few things, like what is the difference between permutations and combinations, and in what situations do we use each one of them. So after this lecture, basically you should be clear about using permutations and combination, like when to use what. And let's jump into it now. So we'll be looking at 10 problems after the few initial concepts to make our understanding of things clearer. Okay, so first let's look at the basic definitions here. So what is a combination? So when we select R items from N items, we use combinations. So for example, one example could be, let's say we have around five, so we have exactly five students in a class. So this is, let's say, a class of students, and these are called five students, A, B, C, D, and E. Now let's say we have to select two students for a particular let's say a competition, who will basically represent this particular class. Then what is the number of ways we can do so? We can either select AB, AC, AD, AE, then we can have BC, BD, BE, CD, CE, or DE. So here, as you can count here, there are 10 combinations here. Now let's see how to get this using the combination operator. So one thing I would like to bring your attention here is, we used a case AB, but we did not use the case BA as a separate case. We only used AB. So why is that? Because whenever we are selecting two students, we are not giving different positions to those two students. So both these students, let's say if we have selected A and B, then both of these students, A and B, will have equivalent positions. So there is no differentiation between the two positions of the two people selected. So therefore, the total number of ways we can select two students out of five students here is 10. Now let's see how we can solve this using the, instead of counting, like how can we solve it using the combination operator. So the combination operator is represented by NCR, where N is the total number of items, which is 5 here, and R is the total number of items to be selected, which is 2 here. So 5C2 can be written as 5 factorial upon 2 factorial 5 minus 2 factorial. So basically the general formula for NCR is nothing but n factorial upon n minus r factorial into r factorial. Now why we got this particular formula? So first thing here is, this is equal to 10, and now why we got this particular formula, we look at it after when we have done with what is permutation. So now let's see what is permutation. So permutations is nothing but total number of arrangements for n items when we take r of them at a time. So once again, let's say we have 5 students, A, B, C, D and E. We are to select 2 and arrange them on seats. Let's say we can call the seats X and Y. Now, what are the different number of arrangements possible here? So let's look at first using the counting procedure. So let's say the seats here are X and Y. So one is AB and one is BA. Now note that here AB and BA are different, unlike the case of combinations. So that is why each combination here will have 2 permutations, which is nothing but 2 factorial permutations. So for R item selected, there would be R factorial permutations. Therefore, now the permutation operator is represented by NPR. So what are we doing in permutation? We are first selecting R items. So that can be done using the combination operator. And then we are arranging these R items in R factorial ways. So let's simplify the formula for this. So we saw earlier the formula for NCR is this, and then we multiply it by R factor. This gets cancelled out. We are left with n factorial upon n minus R factorial. So this is the required formula for permutations. So now using these concepts, let's look at a set of 10 problems which will make things clearer. Okay, so let's jump into the problems now. Okay, so the first question here is there's a team of 5 people that is to be selected from a group of 10 students that will represent the school in a competition. So find the number of ways to make the selection. So once again, there are 10 students here and we have to select 5 of them. So this is actually the same example what we saw earlier, and the total number of ways to do so would be 10C5. So you can further simplify this, but we would not be doing it here. We can leave the answer on 10C5. Okay, the second question is a race between 10 people takes place. There are prizes for first, second and third spot in the race. Find the number of ways in which the prizes can be distributed, assuming that no 2 students finish the race together. So the first thing here is we are selecting 3 students, or select 3 people out of 10. So this is a combination, but 3 people selected here don't have the same position. So we actually need to arrange them in 3 different positions, that is first, second and third position. Just like we saw in our previous concept, we used X and Y positions for A, B and then BA. So similarly, we have 3 positions here and we are selecting 3 people. So the total number of ways to do so would be 10P3, which is nothing but 10 into 9 into 8. So this comes out to be 720. So this is the required number of ways we can select 3 people and then arrange them into 3 positions. So these 2 questions basically shows the basic difference between the combinations and permutations. So now let's jump into the next set of questions. Okay, so the third question here is find the number of ways to divide 10 people into 2 groups of 5 each. So instead of looking at 10 people, we first look at 4 people. Let's say A, B, C and D. And we have to divide it into two groups of 2 each. So just to basically understand the concept, we are first taking a smaller example here. So what are the possible groups here? AB, AC, AD, BC, BD, CD. So just like we saw in combinations, this is the case here. Now the problem here is that we are dividing these 10 people into two groups of 5 each, and here we are dividing 4 people into two groups of 2 each. So the problem here is when we selected AB, the other group is automatically CD, and when we are selecting CD, the other group is automatically AB. So in a way, these two cases are similar to each other. So therefore, there's a depermutation which is required here using a factor of 2 factorial. So just like AB, CD, CD, AB, we will also have AC and then BD. These two cases will also be similar. And similarly, AD and BC will be similar. Therefore, the total number of cases would actually be just 3. And how we are calculating this? We are using selecting 2 people from 4, but we are depermuting using a 2 factorial number here. And therefore, we get 6 upon 2 equal to 3. Now, coming back to the question, we had 10 people. So this is question 3. And we are selecting 5 each from them. And therefore, the total number of ways would be 10C5 divided by 2. We use the same concept which we just saw. So this is the required answer. Now the difference here, so after doing question 4, things will become clearer, like why we did a depermutation here. So you don't have to worry right now. Okay, looking at question 4, find the number of ways to make 2 teams. So red team and blue team from 10 people and both teams having 5 people each. So here we can select 10C5 people, but we are assigning this 10C5 people to, let's say, red team. Then the rest of them will automatically go to the blue team. So here the 2 teams which are selected, let's say A, B. So let's again look at an example of 4 people. So let's say we are selecting for the red team. We can select AB, AC, AD, BC, BD and CD. Note that here for the red team specifically, there are 6 ways to select 2 people for the red team, and the rest 2 will automatically go to the blue team. So therefore here the groups selected are different, and therefore no depermutation is required. So whenever we divide people into 2 groups of equal size, we need a depermutation. But whenever the 2 groups are distinct from each other, no depermutation is required, and therefore the answer to our original question here would be 10C5 and not 10C5 upon 2, which we saw earlier in question 3. So 10C5 is the required answer for 4. Okay, looking at the next set of questions now. Find the number of ways to distribute 9 identical balls to 3 kids equally. So kids, so let's look at 3 kids, A, B and C. Kids are always distinct from each other. So obviously a person is always distinct from another person, and therefore the kids are always distinct to each other. So we can consider these kids as 3 buckets, but which are different from each other. So let's call them A, B and C. Now we have 9 identical balls here. And we have to distribute these 9 identical balls to 3 kids, but equally. So we are giving each kid 3 balls. Now, as the balls are completely identical to each other, we can give any 3 balls to each one of them, and we will always get the same result. So we give 3 to A, 3 to B, and 3 to C. And therefore, there is only one way to distribute 9 identical balls to 3 kids equally. Now, looking at question 6, find the number of ways to distribute 8 identical balls to 3 kids. So once again, we have 3 kids here. Now 8 identical balls to 3 kids such that 2 of them get 3 balls each. So 2 of them are getting 3 balls and 1 of them will automatically get the remaining 2 identical balls. Now the difference here from the previous question is that one of the kid here gets 2 balls and rest 2 kids get 3 balls each. Therefore, we are to select one kid who gets 2 balls. Therefore, total ways to do so would be 3C1, which is 3. So 3 is the required answer here for problem 6. Okay, looking at the next question now, question 7. Find the number of ways to distribute 9 distinct balls to 3 kids equally. So once again, looking at question 7 here. So here the difference is we have different balls. So all the balls are distinct from each other. So once again, let's make the 3 kids as A, B, and C. And let's say we have the 9 balls as 1 to 9. So we have numbered the balls from 1 to 9. Now, as we are again distributing the balls equally, still each kid gets 3 balls each. Okay, the catch here is that each ball is distinct from each other. So which kid gets what numbered ball becomes important here, which was not the case when all the balls are identical. So let's say first we select 3 balls for A. Next, we select 3 balls for B. Rest 3 balls automatically goes to C. Therefore, the total number of ways to do so is 9C3, where we are selecting 3 balls for A, then 6C3, where we are selecting 3 balls for B from the remaining 6 balls, and 3C3. This is automatically 1 because there's the rest of the 3 balls are anyways getting to C, and therefore 9C3 into 6C3 is the required answer. Okay, looking at the next question, question 8. Find the number of ways to distribute 8 identical balls to 3 kids such that 2 of them get 3 balls each. So here, once again, we have 3 kids and we have 8 balls. So the thing here is the balls are not identical to each other. So let's number them. And we have 8 balls. Now one kid is getting 2 balls. So how do we compute the total number of ways here to distribute the balls? We first select a kid who gets 2 balls. Then we select 2 balls out of 8 balls for that kid. Next, we select 3 balls from remaining 6 balls for the next kid, and rest 3 balls will automatically goes to the last kid. Therefore, the total number of ways to distribute balls here is computed as 3C1, where we are selecting the kid who gets 2 balls, then we are selecting 2 balls for that kid, and finally we are selecting 3 balls for the next kid, and the last kid will automatically get the remaining balls. So this is the required answer here. Okay, question 9. Find the number of ways to distribute 10 distinct balls to 3 kids given that each child could get any number of balls and each of them may or may not even get any ball. So there are 10 distinct balls, and once again there are 3 kids. So so basically what we are given here is that each ball can be given to any of the 3 kids. So what is the number of ways to distribute ball 1? There are clearly 3 ways: A, B or C. Similarly, for ball 2, again there will be 3 ways. It can be again given to either A, B or C, and so on. Therefore, for 10 balls, total number of ways is computed as 3 for ball 1 multiplied by 3 for ball 2 multiplied by 3 for ball 3, and so on. This is 10 times for 10 balls. Therefore, 3 raised to power 10 is the required answer. Okay, going to the next question, we have find the number of ways to select 7 balls from a box of 13 balls. So we have 13 balls here. Given that 10 of them are identical, so we have 10 balls which are identical to each other, and rest all 3 are completely distinct from each other. So let's say we have X, Y and Z. These 3 are distinct from each other. Now we have to select 7 balls here. So this we'll be doing using the counting method. So this is a good question from CAT perspective, since we have seen in the previous year's CAT exam that there were some questions where counting method was necessary and there was no other way to get the final answer, and that is why this becomes important for us. So how can we select these 7 balls? So what are the different ways we can do that? We select all identical ones. Now, as all are identical, there will be only one way to select them. So we can actually take any 7 of these 10 balls. We will always get the same result because all the 10 balls are identical to each other. Next, we select 6 identical and 1 distinct. Now there are three distinct balls, X, Y and Z. So one distinct can be selected in 3C1 ways and rest 6 will automatically be selected in one way, because we can select any 6 of these 10 identical balls, we'll always get the same result. So total there are 3 ways here. Next, 2 distinct balls and one of the identical ball. So here we are selecting 2 out of these 3 XYZ and one of the identical ball. So again there are 3 ways here. Next, we are selecting all the distinct balls. So there's only one way where we select X, Y and Z. So the total number of ways here is 8. So we simply added all the 4 cases. 8 is the required answer. Okay, so that is it from this particular lecture. If you have any doubts, feel free to post your doubts in this particular Facebook group. Feel free to reach out to me regarding anything about the exam or any question. Yep. Thank you.